Okay, this assignment's kind of twofold. The front part is all review. Okay, it should be review. We're going to touch on the front page just a little bit today. We won't do, we'll do a few problems on the assignment over the front page. The main lesson, I guess, is the second page, but I just want to make sure the front page, the things on the front page are cemented in, okay, and we feel solid about that stuff. So we're talking about exponents, really, okay, and on the front page there's all these properties that, we have to be able to use and apply with exponents. Now, to be honest with you, I don't really care if you know the names of these things. I'll let you know, I will probably refer to them every once in a while as the names. More importantly, I want you to understand how to apply the property. I don't care about the name, I just want you to be able to do the math, okay? So, for example, the first one is called the product of powers, and here's what this means. It means that if I have an exponent, and we'll just call it like A. Give me 1 second. Because when I make these charts, I center them.
Are you still recording?
Yeah, I am still recording, I think. I center them, and then once I write them, it changes. So if I have A to the M times A to the N, that is going to equal A to the M plus N. And you're like, what? What does that mean? Well, that's why I've got another box here. We're going to do it with numbers over here. So if I have, let's just say, if I have x to the second times x to the fifth, well, I'm going to add my exponents. Added my exponents over here, m plus n. So this is going to be 2 plus 5, which is 7. So our answer here would be x to the seventh. All right, so if you're multiplying things that have the same base, they both need to be x's. Here, x and x is our base. Guys, when I say base, I'm referring to our big number. We're going to add our exponents. Any questions there? All right, now a power of a power is this situation. Is when I do, let's say, a to the m, and I'm taking that to the n power. So it's a power of a power. Okay, in this situation, we are going to multiply our exponents. So this would be a to the m times n. All right, so I'm going to make a new one up here. So let's say if I've got y to the third power, and that is to the fourth power, well, that is going to be y to the 12th power. If you want to know why these are, I can explain them.
Yeah.
You want to?
No, you said why these are.
Uh-huh. If you want to know like why these work, I can definitely show it to you, and they don't take long, but just for time's sake, I'm not going to do that. The next one is a power of a product property. And here's what this means. Let's say I've got A times B, and that's both to the M power. Okay, so I've got two things that are being multiplied together, and that the whole thing is to a power. Well, this power, I kind of say, hey, it's like distributing, essentially, but that power goes to both things only if it's multiplying there. All right, so this is going to be A to the M times B to the M. All right, and if I, again, apply it to a situation, let's say I've got 3x, and that is squared, which we've came across this situation before. If it's 3 times x squared, well, I need to square the 3, and I need to square the x. So this needs to be 9x squared. All right. Now, negative exponent. If I have, let's say, a to the negative m. Rule of exponents is we never like negative exponents. Okay, we don't like them. We want to get rid of them. Yannick? No. We don't like negative exponents. We want to get rid of them. And here's how we do that. This essentially, guys, as a fraction is over 1. Okay? So to get rid of negative exponents, we're going to take the reciprocal of it. Or essentially, if it's in the numerator, take it to the denominator. If it's in the denominator, take it to the numerator. So here, this would be 1 over a to the m. Okay? So let's say I've got 4 to the negative third power. A common response would be negative 64, and that's wrong. Okay? Don't think of it as a negative. Let's get rid of the negative. And so in order to do that, it's currently in the numerator. I'm going to move it to the denominator. So this is going to be 1 over 4 to the third, because when I move it to the denominator, it now becomes a positive exponent. Now, what is 4 to the third? 64. So this is actually going to be 1 over 64.
You can just flip it.
Correct.
You don't need to like divide or anything. You just put it there.
You just move it, yeah.
Okay.
Yep. Okay. 0 exponent. So anything to the 0 power, I'll just call it a to the 0, equals 1. Anything to the 0 power is 1. So for example, 346 to the 0 power equals, all right. Now, the quotient of powers says this. If I have a to the m divided by a to the n, well, earlier, guys, and let's see here, in the very, very first one, we were multiplying, and what did we do to our exponents? We added. So if we're now dividing, what do we do with our exponents? We're going to subtract, you bet. So this is going to be a to the m minus n. So let's see here, if I had x, let's see, to the 5th power divided by x squared. Okay, when I subtract them, 5 minus 2 is 3. Now, I think a better way to do this, okay, would be just to think about canceling. Okay, I can cancel two of those and cancel 2 of those, so now I'm left with 3. So my end result would be x to the 3rd power. Okay, so if I did another one like m to the 3rd and divided by m to the 10th. And here's why. This always kind of confused me, because I need to do m to the, I'd have to do the 3 minus 10, which is m to the negative 7th. But remember, we don't like negative exponents, so we need to get rid of that. It gets kind of confusing. So here's what I want to do. Find the lower exponent, which is in the numerator, and I'm going to cancel 3 of them from there. And I'm going to cancel 3 of them from there, which makes this the 7th. So what do I have in my numerator now? Yeah, I've got 1, because I took all of the m cubes away in the numerator. This is 1 now over m to the 7th. So I think that personally is a better method to do that. Last one is called the power of a quotient. Meaning, if I could have, let's say, a over b to the m power. Well, so if I have a fraction to an exponent, that exponent is talking to the numerator and that exponent is talking to the denominator, it would be a to the m divided by b to the m. All right, so for example, if I had x to the, I'll do just x over 4, but I'm going to square that. Well, I need to square the numerator, so that'd be x squared, and square my denominator. What's 4 squared? 16. So x over 4 squared would be x squared over 16. Okay, let's dive into a few examples here. So we're going to get this kind of cranked up a little bit because we're going to be some harder problems. Okay, Here's my first question on this first one. Do we have to FOIL this? The answer is no. Why do I not have to FOIL this? Great. There's not addition or subtraction with inside the parentheses. Okay, that's when we FOIL. So essentially, the parentheses here aren't doing anything. Now, what we need to do is combine essentially like terms. So x to the fifth and x to the negative third, I'm multiplying them together. So what do I do with my exponents? We add them. So this needs to be x to the second power, great. And then y to the 11th. And there we are. Okay, going to the second one. Here's a situation where I have this 4 out here. Okay, so it's a power of a product rule where this 4 needs to go to both whatever's inside there. All right, so what do I do with my exponents in this case? Multiply. We add it over here. We need to multiply in a power of a product rule. Okay, or a power of a power rule, I should say. A to the negative 8th and b to the 24th, and nothing's happening here, so I'm still going to have a cubed and b to the negative 5th. So now what should I do? Just add my exponents. You bet. I'm going to get a to the negative 5th and b to the, that's 19th, right? Now, is that my answer? What's wrong with this, Liam? Negative exponent. What should I do with this? Okay, flip it. Now here's the deal. I'm not going to move the whole thing because b to the 19th, there's nothing wrong with b to the 19th. It's just a to the negative 5th. Okay, so I refer to this as kind of like cutting things out, all right, editing it and like pasting it in. Okay? So if I cut this guy out of here, make it positive, move it to the bottom, my final answer would be b to the 19th over a to the positive 5th. So like I'll cut it, I'll edit it, make it positive, paste it on the bottom. Because there's nothing wrong with b to the 19th. That's positive, so don't change that.
It was the other way around. Like if it was A19 and B negative 5, what would you do?
Then we would move the negative one.
Just to the top because.
So if that was, I think what you said, if it was a to the 19th and b to the negative 5, is that what you meant?
Yeah. Like,
so I would move this guy now, and I'd call that a to the 19th over b to the 5th.
okay. You just.
Yep. Find the negative one and move it.
Okay.
Okay, now this next one, I've got this whole fraction, okay, and everything's to the third power. So I need to take everything to the third power. All right, so I need to take negative 2 to the third power. I need to take a to the 4th to the third power. What's a to the 4th to the third power? A to the 12th. And then my denominator should be b to the 6th. Now, never leave a number to an exponent because we can always evaluate that. What's negative 2 to the third power? Negative 2 times negative 2 times negative 2. Negative 8. So my final answer here should be negative 8, a to the 12th, over b to the 6th. I can't cancel my exponents here because I have a's and b's. Okay, now if they were both a's, then I could think about canceling and simplifying there. Okay, moving on to the next one. First of all, let's diagnose this number issue. Okay, when I have a number, if I just had 15 over negative 3, what does that reduce to? It reduces to negative 5, right? So I'm going to have, if I think about this, I'm going to cancel, I guess, 3 there, and cancel 3 from 15 to make this 5. So in my answer, I'm going to have 5 in my numerator, and actually I'm going to make that a negative 5. we usually take the negative sign and move it to the numerator. Now, looking at my c's, I want to think about canceling. So I've got 2 of them in the bottom, so I'm going to cancel those and cancel 2 from there to make that a 3. So I'm going to have c cubed in my numerator. And then I'm going to cancel 3 d's from the top. Cancel 3 of them from there to make that a 4. So in the denominator, it'd be d to the 4th. Questions there? Again, everything, numerator and denominator, needs to be to the 3rd power. So I'm going to multiply my exponents here. So I'm going to get x to the 12th, y to the negative 6th, over x to the 9th, y to the 18th. Okay, now I've got x's in the numerator, x's in the denominator. I can think about canceling those. All right, so I can cancel 9 of them from there and 9 there to make that 3. So in my final answer, I'll have x to the 3rd power in the numerator. Okay, now I've got y's on the top and the bottom, don't I? But the y in the numerator is negative. Again, we don't like negative exponents, so I'm going to think about cutting this guy out of here and pasting it in the numerator. So now in the numerator, I have y to the 18th and y to the 6th, which makes it,
Y to the 12th.
careful, because this becomes y to the positive 6th when I move it down there.
Y to the 24th.
Y to the 24th. Because when I take that thing and I cut it and edit it and paste it on the bottom, it now becomes positive. So I essentially have 2 fractions here that are being multiplied. If I have 2 fractions that are being multiplied, essentially it's 1 fraction. Okay? So when I'm going to rewrite this and kind of combine like terms a little bit. So I'm going to get x to the 2nd, and I have y to the negative 3rd and y squared. That'll make what? Yep, y to the negative 1st over 3y squared. Actually, I'm going to rewrite this so it's x to the negative 4th and y.
Line supposed to just be a line, like right? You just
What?
pass right through it. Like when it's supposed to be.
So if you're multiplying 2 fractions, okay, and I'm multiplying everywhere, okay, I'm not adding it or subtracting anywhere, it's really just one big fraction.
Okay.
It's the same thing. All right, and now we can think about canceling. Again, I got x to the negative 4th here. I'm going to cut, edit, and paste that thing in the numerator. So now it's going to be x to the what on the numerator?
X to the 6th.
X to the 6th, great. And then I've got this negative 1 here. So I'm going to cut, edit, paste that guy down here. So that'll be 3, don't forget the 3, and then y to the 3rd.
The 3 stays down there.
Nope, that's a great question. Nope, the 3 stays down there. Hopefully some of that stuff rings the bell from Algebra 1, but as some of you know, it's been a while since Algebra 1 with geometry in between and so on. So just kind of want to clarify that. We won't see a ton of that stuff today, okay? We'll see some of it, and I just wanted to kind of hash some of those things over so that way we have a better understanding. We will see that stuff next period, which is going to be what, on Tuesday. So we will see this stuff again on Tuesday. Okay, move to the next page. Now, the assignment's not hard, okay? The assignment's not hard, it's a little bit different. And actually, let's go back to the front page and I want to talk about our objectives. What we're trying to do is to find nth roots, okay? Find nth roots, kind of like we talked about in our bell ringer. We're going to evaluate expressions with rational exponents. And we're going to solve using nth roots. Now, if we look up here, the chapter is titled Rational Exponents. Rational exponents means an exponent that is a fraction. Okay? An exponent that's a fraction. Fractional exponents mean rational, because rational means it can be written as a fraction. So over here, it says find the indicated real nth root. And I want you to write this at the top. I want you to write n of a. So the nth root of a. That is essentially what we're doing here. So we're given our n and we're given our a. So this is going to be the cube root of negative 216. Now, it's an odd root. Does that mean we need to do plus or minus? No, it does not. So we will not do plus or minus here. Okay? And notice here in the directions it says find the real. Real means it's not going to be imaginary. So we don't really have to worry about imaginary if it says real like that. So what's the cube root of 216? Meaning what times what times what is 216? Let's make a list right here. Actually, let me pause. Okay, so the cube root of negative 216 is negative 6. Great. All right, so this is going to give us the fourth root of 81. What's the fourth root of 81? Plus or minus. Since it's an even root, we better say plus or minus 3. Because negative 3 to the fourth power is going to get us 81. As well as 3. Okay, and then the fifth root of 243 is 3. We don't need to worry about positive or negative, plus or minus, because it's an odd root. Any questions about those? What's that? Easy. Okay, now let me talk about rational exponents here. So this is a to the m over n power. It's a fraction. Okay? Now, I'm going to write this as a to the 1 over n to the m. What did I do there? I took m over n and I broke it up, didn't I? I broke it up into 1 over n times m. I just broke it up. Because 1 over n times m is m over n. Okay, and you'll see why I did that here in a second. Okay? Now, I want everyone down here to write this. Power over root. Because, let's get real here. Guys, fractional exponents can be confusing. We want to transform fractional exponents to look like this, and we can do that. Okay? Now, what this means is, our numerator is our power. Okay? Our denominator is our root. So this would be the nth root of a to the first power. Okay? So whatever's in our numerator, I'm going to change. I'm going to back this up. I want everyone to erase this. If you're in pen, I'm sorry. If you're in pen, I'm sorry. I'm going to teach you guys differently. I don't like that. I want everyone to think of this. Power over root. The numerator is our power. Our denominator is our root. So this is going to be the nth root of a to the m power. The nth root of a to the m power. Guys, this will make more sense when I start throwing numbers in there. Now, we have a negative exponent, and remember, whenever we have a negative exponent, we want to move it to the bottom. So I'm just going to flip this a little bit, and I'm going to call this 1 over the a to the m over n. So it just becomes positive. I just move it to the bottom and it becomes positive. And now I want to think about, this is my power and this is my root. So I'm going to do the nth root of a to the m power. Okay, let's get to some problems here. 16 to the 3/2 power. Well, again, my numerator is 3, so this is going to be my power, and my root is going to be 2. So I want to do the second root. What's the second root? That's a square root, right? Square root. So we usually don't put a 2 there. So it's the square root of 16 to the 3rd power. Okay, and it says here, evaluate each expression without using a calculator. So we're going to try not to use our calculator.
So square root of 16 is 4, so we just do 4.
Great. Square root of, we're going to work inside out. Square root of 16 is 4. So now 4 cubed is?
56.
Oop, 64.
So we use the.
Let me just put this in. Let me put this in simpler terms, guys. That's ugly. Okay, it's hard to think about a fractional exponent. So we're like, you know what? Let's get rid of that. Okay, and we're going to think about as a roots, because I think we're better at thinking about cube roots and fourth roots and square roots rather than fractional exponents. So if I rewrite it as a root to an exponent, I think we can evaluate that a little bit easier. Okay? So let's think about this. First of all, I have a negative exponent, don't I? Do not like negative exponents, so we're going to make this the reciprocal. So I'm going to make this 1 over 32 to the positive 3/5 power. Okay, then I'm going to rewrite it and call this 1 over, my power is 3 and my root is 5. So the 5th root of 32 cubed. So what's the 5th root of 32? That's 2. So now it's really 1 over 2 cubed, which is, it's 2 cubed. Is 8. So this would be 1/8. Okay? Think about that one on your own. Go. So this should be the square root of 4 to the 5th power, right? What's the square root of 4? 2. And to the 5th power is 32. Now, I was just checking there. You know, the 4th root is, or excuse me, the square root is an even root, so we should think about positive or negative, right? But the book doesn't have that. I'm not exactly sure why. So I'll look into that. We'll really get into positive or negatives down in example 4.
Would you want us, like how you said it'd be plus or negative, would you want us to put like...
Again, the book doesn't have them like that, and I don't know exactly why, so I'll look into that a little bit. Okay?
Would you have us do it like that?
I wanted to do it how the book does, so I'm going to teach you that way. Now, it says evaluate these with a calculator. Okay, so we can do these in our calculator. So everyone get your calculator out. And again, my calculator is broken on my screen, so I need to go grab mine. I'll step you through how to type these into your calculator. Okay? Obviously, if you type in 9, okay, 9, and then do your exponent button, you can type in 1 divided by 5. You can do that, and hit enter, and this gets to be kind of ugly, right? Which is fine. So we should round to the nearest 2 decimals, which is going to be 1.55. 5 is right. Now, here's what I want. What is 9 to the 1/5? Well, this would be our power over our root. So isn't this the 5th root of 9?
Yeah.
Yes.
Okay, so I want everyone to hit the 5 button. Okay, hit 5. And then hit the math button, which is towards the top left. And then scroll down to number 5 where it says that X root. Now we can type in 9 and hit enter. And we get the same answer. Do you see that? Okay? So, number 12. I don't want us to do fractional exponents. Let's transform it. Isn't that going to be the 8th root of 12 to the 3rd power? Would you guys agree with me there? This would be the 8th root of 12, and that's to the 3rd power. So hit 8, and then the math button, and then go down to number 5 and hit enter, and I'm going to type in 12. Now, we need to make sure that we don't just raise that to the 3rd power. So I'm going to hit enter here on the 8th root of 12 and hit enter, and I get what? What do you guys get in your calculator?
1.36.
1.36. Now I'm going to raise that to the 3rd power.
To take 1.36 to the 3rd power.
Yep. And I think we should get 2.54.
Yes.
Okay, same idea here. I'm going to hit the 4, and I'm going to go to math, go down to number 5 option there, and then I'm going to hit 7. So I'm doing the 4th root of 7 and hit enter. Excuse me, and then raise that to the 3rd power. Okay. Now, can we use our calculator when it says don't use without a calculator? I'm not going to stop you, but right now I'm just telling you the way I'm thinking of it. I will have a section on the test that you can't use your calculator on evaluating some of these things. Okay. The last part is solving some equations. Okay, and it says find the real solution. So again, we're thinking, hey, there's not going to be imaginary numbers. But here, how do I solve that first one? Yeah, we're going to divide both sides by 4. And so I'm going to get x to the 5th power equals, I think that's 32, right? Now, to get rid of x to the 5th, we need to do the, not the square root, but the 5th root. So what's the 5th root of 32? 2. Now here's the question, and you know how when we put the square root sign in ourselves, we have to think about plus or minus? That's kind of what it comes back to is, hey, we put the 5th root in ourselves. Do we have to worry about plus or minus here? No, because it's an odd root. So the answer here would just be 2. Okay? Now, since the whole expression x minus 3 is to the 4th power, we need to get rid of that first. So we're going to take the 4th root of both sides. All right, so now the 4th root and the 4 go away. So guys, watch this. I'm going to have x minus 3. And do I know what the 4th root of 21 is? I don't. Okay, so it's going to be a decimal, but I don't want to do the decimal right now. Okay, I'm going to do that at the end. So I'm going to have the 4th root of 21. Do I need to do plus or minus there?
Yes.
I do. Now how do I solve for x? I'm going to add 3 on both sides. Now can I add 3 to the square root of 21? No, I'm going to kind of fit that in right there. So x is going to equal 3 plus or minus the 4th root of 21. Okay? Now, I'd be okay with that answer, It's the most accurate answer. But when we do our assignments on the computer, they're going to want those, because on the computer it's like this. It says x equals this. And what does this little tilted equal sign mean?
It may be like more than one.
It means approximately. So when they do that, they're going to want a decimal. Now, so here's what we need to do on our calculator. We need to do 3 plus the 4th root of 21 and hit enter. And 3 minus the 4th root of 21 and hit enter. So we're going to get 2 answers.
Mr. Cole, how can I do the 4th root?
You're going to hit 4.
Yeah.
And then hit math. And go to that one. Makes it the 4th root. So when you guys do 3 plus the 4th root of 21, what do you guys get?
5.1.
5 point what? We're going to round to 2 decimal places. 5.14. And we do 3 minus the 4th root of 21. 0.86.
So you just do one with adding 3 and one subtracting.
Correct. You're going to do 3 plus that and 3 minus that. You bet. All right, last one here. How do I get rid of the half? Yep, we're going to multiply that by 2 on both sides. And so I'm going to get x to the 5th equals 1024. Now I need to do the 5th root. Do I need to worry about plus or minus?
Nope.
I do not. It should be 4.
Bang, bang.